Right. Hi, everyone. So yes, just now we touched about the fundamental, and now we are touching about some example. When I look at this example and I look at um the the sample 1, 2, 3, I know this is the RV, and I further check this is the probability mass function. This is the RV. Okay, to write it in a PMF format, so we analyze slowly. So probability to guess x equals to 1 is 1 over 3. Probability to get x equals to 2 is 1 over 3. Probability for us to get x equals to 3, also the same value. So otherwise means, besides that, it's all equals to 0. If you look properly, this one, I'm not sure you can see it. So this one is a small capital. Okay, we can use this to convert into PMF graph. So the x value is 1, 2, or 3 that have 0.33 value. All right. So next, DRV. We convert the probability mass function to cumulative distribution function. How we do that? Very simple, like I mentioned to you, but you have to write like this. For x equals to 1, which means the cumulative is x equals or smaller to 1, right? X smaller or equals to 1, it's px equals to 1, correct? So it's equals to 0.33. So next, x equals to 2. When x equals to 2, I counted x equals to 2 plus x equals to 1. Therefore, I get 2 over 3.67. Okay, clear? So next, when x equals to 3, so when x equals to 3, so it means x smaller or equals to 3. So we add all together and get n. So our summary CBF value is 0.33, 0.67, and 1. So when we draw the line, actually, to be honest, we shouldn't draw the horizontal line. We just draw the point, okay? Just draw the point. It's a cumulative anyway. So, and that represent your CBF, okay? Next, so we know about the PDF, we know about how to find the probability, we find the cumulative, we also need to learn about the mean and standard deviation. So for example, I check all the effects in all the compressor that happen in a month or a week. So turn out that some of the compressor have one defect, some of them have two defects. And this is a raw data. So you can add them together and divide it to how many compressor. All right. So you get 1.4. Or you can make it into systematically in a table form, x equals to 1 or x equals to 2, and then you convert into probability. How so? It's 6 over the total of the frequency. So it's 0.6, 0.4. So in order to get the mean, so 1 xi times pxi, can you see this? So, and you sum all of them together, like this one. Xi is 1, okay, pxi for 1 is 0.6, plus 2 times 0.4, and that is the total value. Okay, remember this only can eligible for DRV. Okay, I would like you to try this one and we discuss for the next week to try to find the mean for this. Let's try for example. There are also few expected value or mean rule law for DRE. For example, I have a constant and I have a variable. I can take the constant out. So I can only focus on the variable and the C remain as constant. If I have the only a value, the constant, then that is my expected value. I don't need to do much. But if I have a big system that I have two functions, remember this is discrete random variable, so I can add them together. Okay, if I have x and y is discrete random variable and they are independent, you can separate them individually and add them together. It's pretty simple. Okay, expected value for DRV, there are two ways. One is the one that I showed you just now, okay? Another one is you can use, let's say you have a lot of number. That example is just so little. So that your x minus the mean, the total mean, power of 2 times the probability of each, and then you add them together. Or you can use your x power of 2 times the probability value and minus the mean power of 2. Well, that's depends on which one you feel comfortable. So let's try this. And in fact, you can use both. It should having the same value because it's derived from the same way. So first, try to find whether you can get your mean is 1.3, okay, by looking at this set of discrete random variable data. And then after that, you can choose this way or this way to do the analysis. But in this case, I choose well equation A. So how these two xi, what is xi? Xi is this one, 0 minus the mean power of 2 times the probability. And you do that for all the x and you sum them together. That's the variance. But if you want to get the standard deviation, you need to square root it, and that is your standard deviation. Okay? Okay. So next, I would like you to try using the step number 2, whether you get the same value. Is that okay? Okay, this is another let's try for you. So computer chips, you can read about that, but based on the table, I roughly know I need to find the mean first, and then I would like to know the p smaller or equals to 2. Smaller or equals to 2 means from this part. Right, I can write p equals to x equals to 2 plus px equals to 1 plus px equals to 0 and add them. So find the probability bigger than 1. Okay, that's very simple. So what we can do is 1 minus p smaller or equals to 1. Right. You can do 2. You can do bigger than 1. So you choose x equals to 2 plus x equals to 3 plus x equals to 4. That's it. You also can find 1 minus x equals to 1 minus x equals or smaller than 1. That's it. Okay. So for the variance, you can actually refer to the equation just now. Okay. To find it. That's pretty much. I even give you the answer so that you can do the revision by yourself to make sure you are right. Okay, and this is another trial I would like you to try, and we discuss about this later. Okay, that's it for the DRV. Next, we will move to the CRV, Continuous Random Variable. See you in the next video.